Have you guys like ever wanted to kiss the ground? Like literally? If you have, like I wouldn't blame you. Personally, I have not. But I wouldn't blame you, no judgment. But the ground is so important. Like we're literally on the ground and we have been on the ground our entire lives. Well, what's so important about the ground? Well, there's one aspect about it that makes it the ground. A part of that is soil. Soil is the main thing. It's how we get our food mainly. It's the main medium crops are grown in, and it has so many other benefits. 60 is a really big number. That's when most of us want to retire. I want to retire now, but I can't. But historically, 60 years is really not that long. And unfortunately, that's how much harvest seasons we have left if we keep treating the earth the way we are. But there is hope. Maybe not a lot of it, but it's still there. So, as a person who's grown up surrounded by nature in some ranches, it's my natural hue to be interested within agriculture. So with the hope I have, I studied sustainable agriculture and the environment as well as soil science. It's important to somewhat understand the history to understand the foundation of which we are upon now agriculturally. Essentially, agriculture started becoming popular a couple thousand years ago with indigenous tribes and cultures because their civilizations were growing, but because of their religious and cultural connections to earth, they wanted to sustain it. So they grew in a way which is known as regenerative agriculture. Fast forward a couple thousand years to the Industrial Revolution, mid-1700s, early 1800s. We needed a way to grow a lot of food because our population was expanding so fast. So, a lot of inventions were created, such as tilling, in order to fulfill those demands. Of course, a lot of inventions came after that, such as the tractor and some synthetic fertilizers. But we didn't really quite understand their impact on the environment until about 100 years later during World War II and the Great Depression era. We needed a lot of food to sustain the war that was happening at the time, so we cleared out a huge grassland and tilled it to death. And because of that, we created a really big problem known as the Dust Bowl, which was a really big drought that harmed people physically, emotionally, and it also put us deeper into the Great Depression because agriculture was important at the time to the economy. 8 years later, it eventually cleared up naturally, and the president at the time created the Farm Bill, which a portion of that, around 7% of those net funds, were given to conservation programs, which only a portion of that was given to regenerative agriculture. So we cared, just not a lot, and we still really don't. But fast forward to the early 2000s, late 90s, the term regenerative agriculture was coined. Of course, all these techniques and always have existed and have been used throughout human development, but the term regenerative agriculture was given then. And fast forward now that we have a lot of scientific advancements in knowledge, we have kind of created a lot of new technologies that have sprouted regenerative agriculture to what it is today. But it's still the same for industrial agriculture, so we still rely on that solely too. But I've been talking about soil a lot. What is soil? I mean, obviously this man really loves soil. He's hugging the soil. But what is soil? And no, it is not dirt. Soil is not dirt at all. Soil is a living ecosystem with many different components. One of those being physical properties, which are defined as the quality or property of a substance with a numerical value or unit. Pertaining to soil, one of the main characteristics is soil structure, which is the physical framework soil has, which allows it to operate efficiently. Essentially, soil structure is the combination of particles that form into aggregates, which those also cluster to give soil its physical framework. But what makes up soil structure, or the specific types, is obviously there's quite a bit here, which is soil texture, which is the ratio between the different particles that cluster together into those aggregates. Those being clay, sand, and silt. Ideally, most plants prefer a soil around the lumi, so around 20% clay, 40% sand, and 40% silt. It's important to kind of keep a balance, ideally around those areas, because having too much of one particle will affect its whole composition. It affects quite a bit. It's like if we lose an organ, like if our heart shut down, it affects everything. which moves us into chemical properties, which are defined as a quality or property of a substance that undergoes an alteration that changes its identity. Mainly in soil, one of them is pH level. Most plants prefer a soil pH to be around 5 to 7.5 on the scale because that's when most nutrients are available. If you're too far on either side, then you have more of some nutrients, but you have less of others. Which leads us into nutrients, which like us, we need macronutrients and micronutrients, as does the plants in soil, which macronutrients are just nutrients needed in large quantities, while micronutrients are nutrients needed in smaller quantities, but they're still equally as important. Biological properties are the most important aspect of soil, and they are defined as living organisms and the biological activities that occur within an ecosystem. Soil organic matter is the first and one of the most important biological activities or properties that take place within the ecosystem. Essentially, organic matter is the matter derived from or directly from the remains of a living organism, such as a plant or an animal, which is what it makes compost. Like, we need living organisms such as a banana peel or even like sheep poop is what most ranchers use in order to compost. But essentially, incorporating more soil organic matter, you're incorporating more nutrients through the nutrient cycle. You're reintroducing nutrients back into the soil, which are used for plants. But also, they have a lot of other benefits. They can rebalance pH scale, they can support soil structure, and they can also rebalance soil texture if it's out of balance. But they can also add more microorganisms, which is the next important aspect, the most important, which is the microbiome of soil. Essentially, the microbiome is a colony of microorganisms that exist in the soil around a plant, and they have many key functions, thousands. But when we think of the microbiome, we tend to think of its more important qualities, which are to protect the plant from pathogens. It strengthens the immune system. It can also gather carbon from the atmosphere and store it in the earth and use it as nutrients for the plants and for itself, essentially reversing climate change. It can also grab strayed nutrients and work as a system to get it to the plant. But they can also transform nutrients from their inorganic into the organic form to act as feed for themselves or for plants. They can also decompose things too. They work with the microbiome of other substances to reincorporate those back into soil organic matter. But it's also super adaptable. The microbiome, or a study from a university that had 12 pots of plants, 6 of which were grown in ideal conditions, and 6 of which were grown in a drought-like condition. And they found that over the course of 3 generations, the plants in the dry conditions started growing at the same rate as those in the ideal conditions because the microbiome was able to electronically or electromagnetically communicate with each other and with the plant to adapt to the environment, which allowed them to become more resourceful of their resources. This is where soil science plays into agriculture, as soil science is the key backbone of agriculture and regenerative agriculture, and this is how many of our technologies have advanced thus far to allow us to become more sustainable and know what is sustainable and what isn't, which leads us into regenerative agriculture itself. But what does it mean to be regenerative? Well, it means that we're regenerating things faster than they can be destroyed, as well as sustaining them, which means just conserving everything that is there, all the resources, all the minerals. And because of soil science, we've made key advancements such as no-tilling devices. Tilling in itself is the most destructive agricultural practice in our modern day. Essentially, it's just when you rake the ground to provide or to aerate and provide better water filtration to plants to allow them to germinate. But it's very destructive to soil, and it affects soil as all its properties. It kills the microbiome, it destroys the soil structure. In fact, it erodes quite a bit of soil. It attributes to around 66 of all erosion annually. But no-tilling is quite the opposite. It just these devices poke holes in the ground just wide enough and deep enough for seeds to germinate, which causes 90% less erosion, essentially. It's really beneficial. And if you look outside, this leads us into our next practice. How much of the ground is bare? I mean, we're in the forest, so little to none. So this leads us into cover cropping, which essentially are seeds that are planted or are crops implanted into soil with the sole purpose of guarding the soil from natural means of erosion, like wind and water erosion, and UV rays too. Because of this, these crops are able to reduce natural erosion by up to 66%, which is quite beneficial. But also, when their lifespans are about to be over, you can rake them back into the ground. This is what most farmers that rely on cover crops do. They rake them back into the ground and they decompose into organic matter, which makes the microbiome stronger. The next is crop rotation and polycropping. Industrially, monocultures used to be popular, but they're not as popular anymore. Only about 10% of farmers still rely on them. But it's when you grow the same crops year after year after year, and because certain crops prefer more of certain nutrients, you're just depleting the soil of those nutrients, which leads to a nutrient deficiency. But by changing the crops you grow every year, aka crop rotations, you're still able to be efficient with what you're producing. You're able to produce quite a bit of stuff, but you're also able to limit the risk of a nutrient deficiency. Polycropping is more seen on the regenerative scale on small scale farms, but it's the incorporation of multiple different species within the same patch at the same time. Essentially, this works the microbiome to become super strong. An example of this is different pathogens within soil only attack different plants or certain plants and species. So by allowing the microbiome to have connections to multiple different crop species, it's essentially training the microbiome to become more resistant to those diseases, as well as pests, because it's the same for pests, they only attack certain crops usually. So by training the microbiome to become more resilient, it makes it more resilient to those disadvantages. Which leads us, fertilizers are also another common practice, synthetic fertilizers that is. By applying, usually they're nutrients directly given to plants industrially, but they're really destructive and plants only uptake around 30 to 40% of those nutrients, and the rest of that is just laid to rot, and they're not necessarily biodegradable, so it takes centuries for them to completely go away, and it's common that they run into larger bodies of water which pollutes other environments. It's very destructive. It's the same for pesticides, which are really dangerous. That's why we need to wash our fruits and vegetables before we eat them, because consuming them is detrimental to our health. So imagine farmers like being around them all day and they're like spraying all these crops with these pesticides and they're inhaling them. There's countless cases of cancer and other health effects that are just traced back to these pesticides. But biopesticides exist, and they're not as great because they wear off faster, but they're safe for human consumption, and essentially they're just natural remedies derived from natural things that deter pests. The next thing is a study from a Browns Ranch, which used to farm industrially, but as you see over the course of 20 years, they switched to regenerative agriculture, and they were able to rebuild older soil organic mass, allowing for a strong microbiome, which allowed for more nutrients to be available, as well as healthy soil. A lot of people ask me, like, is there like a best method? The answer is yes and no, because tilling is most impactful. We need to really shift our viewpoints away from tilling. But on the other side, no, because most of these techniques are meant to be used in unison for their max benefits. As seen by this study, they started using no-till, but over the course of the years, they start incorporating different techniques, which allows the soil to be worked in different ways while regenerating it. But these are so good. Like, regenerative agriculture is so beneficial, but why don't we rely on it? It's a really complex situation, socially and politically. Socially, there's some farmers that have grown a certain way for generations industrially, and they may not be willing to make that change, and we can't force them. But on the other side, there's farmers that do want to make this change because they find it more economically better for them, as well as safer for the environment, but they simply don't have the funds to do so, because switching can be expensive at first. But also, through the Farm Bill, there's insurance and subsidies provided, which if something devastating happens to crops, they're not going to financially struggle farmers. But when we're switching to regenerative agriculture, those same benefits are not provided because they're not farming a certain way or producing a certain amount of food. So if something devastating happens to their crops, then they are going to be in debt. And going back to the Farm Bill and their conservation programs, only about $1 billion of the conservation fund is given to regenerative agriculture, which seems like a lot, but it's really not. And those programs have to reject 50 to 75% of qualifying applicants because there's just not enough funds. But there are some solutions, that being more political recognition mainly, because with more funds we're able to transform more people into regenerative agriculture. And it's also known that regenerative agriculture can be just as efficient as industrial agriculture, because by training the microbiome to become efficient and all that biological activity to become more efficient, you're allowing for crops to be grown more nutritiously at the same rate, which is important. Therefore, a deeper understanding of soil science and more research could be really helpful for developing new technologies, as there's a lot of things we yet don't understand about the microbiome that could be beneficial to understanding how we can make newer technologies. But with the little bit of hope we do have, if we all work together to plant a little seed the correct way, it can sprout into change. And that is important for our current world. Thank you.